Alright, so this says lesson 8.6, but it's really the last section of chapter 6. Alright, this is the three-dimensional Cartesian coordinate system. Now our objective here is we want to be able to draw 3D figures and then analyze vectors in space. So this does have to do with vectors, it's just in a different chapter. Okay, so notice something here. There are now three axes that you have, not just an x and y axis, but you have a z axis as well. Notice where they're located. Okay, x and y are sort of flat, and then z is sort of your vertical axis now. Okay, so make sure you understand this point right here is kind of out in space. X, y, z, those are non-zero numbers. Okay, so non-zero numbers. So when you go to plot a point in 3 dimensions, it's going to be out here in space somewhere. Okay. Here's your distance and midpoint formulas. Basically, they're the same as normal distance and midpoint formulas. The only difference is now you're adding z's. So you have x's, y's, and now you have z's. So when you want to calculate the distance and find the midpoint, okay, what you want to do is, so the distance from P to Q in 3 dimensions, you're just going to do the distance formula. So negative 2 minus 4 squared plus 3 minus negative 1 squared plus, okay, all you're doing is distance formula, guys. And then your z's are the third coordinate. So square root 36 plus 16 plus 16. Okay, so that's the square root of 68. Okay, doesn't really say how to leave it. If you took the square root of 68, you get 8.3. Okay, if you round it to the nearest tenth, doesn't really indicate. Midpoint. Okay, midpoint. So you have all these divided by 2. So add the x's, add the y's, add the z's. So your midpoint is 1, 1, 3. Okay? So, like I said, distance and midpoint are really easy to find. You just add the z's to your formulas. Okay, distance formula and midpoint. All right, so spheres are 3-dimensional shapes. Okay, so if you have a point x, y, z on the sphere with center h, k, l this time, and the radius r, this is your equation for a sphere. All right, now remember, for a circle, you didn't have the z minus l squared. You just had x minus h squared and y minus k squared and r squared. Now you're just adding a parenthesis. So really, the standard equation of the sphere with the center and the radius, x minus 2 squared plus, now the y coordinate's 0. So normally you'd write y minus 0, but y minus 0 is y. And then plus z plus 3, remember inside the parentheses you do the opposite, equals 7 squared is 49. So that's all you have to do. Okay, plug your numbers in to the sphere formula. So that's pretty straightforward. Okay, every plane can be written in this form. Okay, now notice the equation equals 0. All right, where a, b, and c are all not 0. Conversely, every first-degree equation in 3 variables represents a plane in Cartesian space. Okay, so what that means is, if you have no exponents and you just have x, y, z, okay, instead of drawing a line, you would have a plane because you're in 3 dimensions. So in 2 dimensions, you'd have a line. 3 dimensions, you'd have a plane. So if you got to sketch this graph, okay, what we want to do is we want to find all of the intercepts. Okay. Whoops. There's more than that. So if we let the first two variables be 0, we get 20z equals 60. Okay, so z is 3. If we let x and z be 0, that means 15y equals 60, so y equals 4. And then if we let y and z be 0, we get 12x equals 60, so x equals 5. So now we're going to plot those points on a three-dimensional plane. So here we are. Let's see if I can do this. That's a terrible line. That's not a good start. So we got a line there, we got an axis here, we got an axis here. So here's your z, here's your x, here's your y. Okay, so on the z-axis we have 0, 0, 3. So we have a point right there. Our y-intercept, so this is the z-intercept. The y-intercept is 0, 4, 0. Okay. And then on the x, 1, 2, 3, 4, 5, right there. Okay, so you find your three intercepts, and then what you're going to do is you're going to connect these dots with a triangle. Okay, that is the plane that we're talking about. All right, so it's very simple to sketch a plane. Okay, find the intercepts, plot them on the correct axes, and then connect the triangle. And it's going to be a triangle every time. So that's how you sketch the plane. Okay, so here are all kinds of different operations that you can do with vectors. Okay, it's the same as everything else. Like all the vector stuff we've done, you're just adding another component. That's all. It's the same exact thing. Okay, so when you're computing with vectors, okay, you have this 3 here. So instead of distributing to 2 components, you're distributing to 3. So you have -6, 3, 12. Okay, here you're adding them, so you just add the components. So -5, 6 plus 5 is 11, -7 plus 8 is 1. See, we're subtracting them now, so 1 minus -2 is 3, -3 minus -4 is 1, and 4 minus 5 is -1. Now remember, absolute value of a vector means magnitude. So we do 2 squared plus 0 squared. Okay, we're doing the distance formula, plus -6 squared. So that's the square root of 40, which reduces to 2 radical 10. Okay, and then the dot product, the last one, so it's 5 times -6 plus 3 times 2 plus -1 times 3. So that's -30 plus 6 plus -3. So that's -24, -27. Okay. So 3 dimensions is very simple, guys. You're only adding one more component to the vector, or you're only adding one more term to your distance formula. Okay, it's the same process. Instead of doing it twice, you're doing it 3 times now. Okay, so that's 8-6 right there. Very simple, straightforward. Hopefully you guys do well with that.